well, basically I didn't grow up. So I stand in front of you today. I'm 56 years of age, and my time as interacting with wetlands has been in Narrogin, a little place called Dryandra, and we used to go there and just used to muck around. We didn't see it as anything quite significant. We just felt there was lots of animals there, and we used to muck around with them, go and catch some tatties, probably get a leech on them, and come back, probably still got the leech on them, and put those tatties in the aquarium, and then rear those tatties, go through their life cycle, and it's pretty much a miracle what happens. So, like, culturally, frogs are quite significant for Indigenous peoples. They are totems, they are food source, they are indicators. You can actually map frogs according to their seasons and see when different things are flowering and food sources are available, or other kinds of things are available. And within non-Indigenous peoples, you know, the experience is probably the same for you guys as being going down to a wetland, might get a couple of leeches like I did, and then when you really want to go down to the wetland, when frogs are active, is when are they usually active? You know, it's when it's night time, and it's usually wet, cold, and windy. You know, sometimes I have problems trying to get people to help me, and so you do have those kinds of things, but I wouldn't change it for the world. Look, frogs have, we're going to go through a little crash course. We're going to give you a 101 on frogology, because if you don't understand the creature that you are talking about, you need to look into your research. You're not going to be hitting the marks. So you've got to understand all the little bits of their biology and their ecology, and why their physiology governs what happens in the ecosystem. They've been subject to a lot of impacts. Whoa. Okay, so habitat destruction's, you know, a pretty big one. It's same pretty much all of our species. But frogs are very susceptible to pH changes. So as the groundwater reduces, the pH can increase, and then the water level, the acid can affect, where it affects it mainly, very much so in the larval and embryonic stages. The egg's got like a vitelline cover to it, and it's very, very sensitive. The adults are affected, but they can jump away. They're not as affected as the larval and embryonic stage, and they can't go anywhere. So they're it. The chytrid fungus, that's been, basically it's been around for about 20 odd years. That affects the adult frogs. It doesn't affect the tadpoles and the eggs. It's like a keratin layer that it's around the lips on the tadpoles, and once the frog turns into an adult, the keratin is spans throughout the skin, and that disrupts the mechanisms of the frog. And then there's pesticides, the biomagnification, so there's direct and indirect. So what do frogs eat? A frog went walking on a summer's day. Well, actually, most of our frogs do not eat mosquitoes, because that's what they had for the wedding, didn't they? Fried mosquito with bread and butter. But they actually eat, there's a little poster out there, and it's got all these little insects. They eat little cockroaches, they eat like little black crickets and things like that. So they eat lots of ground insects. So that's another thing with your revegetation that you've got to understand, is the food source. So then you've got the herbicides. The herbicides can impact them. When I first started working on frogs, I had the honour of working with Harry Butler, and we had a job down at Denmark, and that was to do with trying to work out why the frog numbers were decreasing a lot in numbers And this was, 20 odd years ago. And so Harry said, okay, we're going to go out and follow the parks and gardens out around the place and find out what they're doing. And so, yeah, sure enough, we followed them around, and that was a case of them using surfactants in their herbicides, and surfactants found with car oils, and that was making the witch's brew and killing the eggs in the tadpoles. So that was a mass die-off. Salinity, self-explanatory. The introduced species, I mean, you could add other things to it. The ibises are one of those new kids on the block, and when you see those in a paddock, they are knocking off your dung beetles, and they love frogs. Having said that, frog biomass is food for other frogs, and I'll get to that in a little while. Foxes, they are deadly on frogs, especially the burrowing species that are really declining. You can go out and they'll hear those frogs calling. Which are the frogs that call?
The male frog.
Male frogs? Yeah. So what do they call for? All right. A bit of l'amour. But they actually do have another call as well. There's about 3 different types of calls. We'll get to that. And then there's an assessment at the end. All right. Well, climate change. Yeah, climate change is it's the big elephant in the room, and that's affected them because the way the hydrology is happening with the amount of abstraction that's going on, reduced recharge, the superficial wetlands that are really important for our frogs. A lot of our short-range endemic frogs, they're disappearing. So that's one factor. The increased fire, that's another factor. And then on top of that, when they actually go out and deal with the fire, the actual water, the retardant in the water is deadly to frogs as well. So there's like another thing to their survival. And yeah, these ephemeral wetlands are the key to their survival, a lot of them. And as I was saying, the impacts, it's a declining scale, but the eggs, this vitelline layer around the eggs, highly sensitive. Tadpole stage, that's the next stage, and then the adults. If these kind of go through to the keeper, they survive. A lot of them do have deformities, and the deformities can show themselves without actually an average person picking up on that. So they can get these little dishes on their heads. They can get the fifth leg that occurs, just doesn't protrude through the chest. And 4% of the population is quite significant, and we do see that in our monitoring. And as I said, all these contribute, the anatomy of the frog, the physiology and the biology all contribute to their decline. A lot of them are short range, and particularly the short range endemic ones. And talking about the hydrology and the vegetation. So when you look at a frog, they live in the air, land and water. So they have interactions with all these species and all this vegetation that they rely on to survive, protection, calling sites, breeding sites. So that's why they're such a good indicator. They live in the air, land and water. And I've put in here estuarine and marine environments. Frogs aren't able to tolerate salty water, but when you're dealing with the land up in the upper reaches, the rivers and the waterways that drain down to those estuaries, if they are healthy, those wetlands will, filter the water and take out the nutrients and the sediments. So that's how they impact on the estuarine and marine environments. The improved wetland condition. So there's a couple of things there. With tadpoles, what are tadpoles eat? Yep. And there's a certain, well, sometimes they eat one another. They get a bit of protein if there happens to be an opportunity. but mainly they eat this film on the plant. And so that film of algae that lives on that plant, they're just by their agitating the water, they take that film of dust, that film of sediment off the plant. The plant is better off able to photosynthesize. So you're improving the quality of the waterway, of the water, because the autotrophs are able to photosynthesize much more effectively. Once you get that effective quality of that photosynthesis, that means your nursery system is allowed to build on that. So I said for the biomass, I want to make sure that everyone here understands when I say biomass. Frog biomass is the eggs, the tadpoles and the frog. So that's 95 of that. 95% is frog food for other animals, including frogs. So when you find that there's a lack of frogs in the system, like I've done different audits for revegetation. One of them was for just up on Rockingham Road here. One of the issues was it was re-veg and it had a lack of bird life. And why was that bird life lacking? You have to go, when you're doing a frog doctor kind of stuff, you go out at night and it's wet, cold, windy, sometimes you get chased by dogs, have a car stolen, all kinds of stuff. But the crux is you find out lots of things. And there were goldfish, there were carp in this system. So what the carp were doing is, you know what carp do? They come along and they just rummage through they degrade the waterway because their foraging habit just happens to silt up the plant, the water. And then they just muddy up the water and reduces the ability of the plant material. And then in come the birds to eat the plant material and the frogs and the tadpoles. So they were making the system pretty hard for the tadpoles to get the frogs to get a leg hold, to recruit and to keep populating. So the carp were the key, were the link in why the birds were reduced bird life. And the increased diversity, because of all the different frogs that are in the system. You can gauge tiger snakes, if I go around, I will see other indicators will tell me what kind of frogs are in the system. Approximately 240 frogs species, thanks to the Frog ID, the Australian Museum, found a few more. Approximately there's 39 to 40 species of frogs in the south west, in the temperate zone. And the majority of them is are ground and burrowing frogs. Why do you think that's the case?
Because it's dry down there in summer and it needs some moisture.
Yeah.
Long hot summers.
Yeah, the evolution's reflected what we live on. We live on the driest inhabited continent on the planet. So our frogs have evolved, and they've evolved pretty interesting kind of habits. So, majority of them are burrowing species or ground frogs. The ground frogs are the ones that are going missing. The ground frogs and the burrowing frogs are the ones that are going missing. So let's do a little bit of frogology to kind of give you, as a segue to the next segment. Frogs. So they've got, this is a frog that's a tree frog because it's got a longer tibia length than the fibia length. Most of our frogs, our ground and burrowing frogs, actually have got a shorter tibia length. Why is that?
You don't have to climb.
Yeah, they're not used for climbing. Yeah, they don't hop around as much. They're used to living in the ground and crawling around and just little hops, but not too far. Can frogs hear? Yeah.
Making a noise for some reason.
And the boys are calling, of course. So when they call, they can hear. Can they see well?
At night.
Yeah, they can see well. And some frogs have got pupils that are vertical, and some frogs have got pupils that are horizontal. And this is a tympanon. So this frog's got a distinct tympanic membrane. We've got tympanic membranes. Our eardrums. This is indistinct kind of membrane. So, frogs have got 4 fingers and 5 toes. Sometimes with males, if you don't hear them calling, you can work out if they are males just because they have this little nuptial spine on the first digit or the second digit. That's so they can grab onto the females. Sometimes the males are smaller, generally speaking, and they have this a bit more muscular legs, but the males essentially call. So if we were to go out frogging now, there's not too many in the way of calling. So sometimes you need to ID them through the nuptial spine. And they can play tricks on you because you can get some frogs that actually change their nuptial spine. Normally they'll be there and then they'll change their nuptial spine when you go down south and find the same species that it's gone to the second digit. This is what people are used to. So we're doing a bit of myth busting in this. Most of our frogs have got claws. Check them out. So, everyone knows what that is. Yeah? That's probably the frog that the West Australian Museum get more calls for than any other frog. It's called the moaning frog. Alright, let's do a quick little... That's a quacking frog. So our frogs have got a variety of calls, and that's a quacking frog. It sounds like a duck. It's a massive 4 centimetres. Pretty bigger. That's a clicking frog. That grows to a massive 2.5 centimetres.
They weren't very imaginative with the names, were they?
No, but it's pretty much on call. It's like, yeah, that's a clicking frog. And they're actually really good for projects. Say, I did the Perth Cultural Centre. We introduced clicking frogs there. The thing is with clicking frogs, they're called most of the year round if there's a little bit of water. But the other thing is, some people have asked, how come you don't actually have frogs here? Well, one of the things I do if I do happen to have frogs is you have buckets of sand. You don't have buckets of water. Because if you look at this biology, you read the poster that's there, most of our frogs don't like a lot of water. And they'll actually drown in water. So there's another thing. Most of our frogs have got claws. Most of our frogs don't like a lot of water. And there's something else for you to kind of look at. What colours do you see?
Brown and grey.
Yeah. I mean, this might not do it justice, but when you hold, this kind of stuff up to them and you get a bit of sand, kind of pour a bit of sand out and you kind of put it out there, just putting it out there. Most of our frogs got claws, they're brown, and they don't like a lot of water. So it kind of goes against and we don't get warts from frogs either. So there's some things that we need to, the reason why we said we've got warts is that frogs they do by nature have this antifungal property of their skin, and they also have other properties like there's Latoria cerealia, and that cerealium is the thing they inject into you when you have a stomach operation to stop your stomach from spasming. And there's all these other things that come from medicinal applications that come from frogs. So you don't get warts. Shall we go through a few more calls, just quickly? So this is an interesting one. This is a bleating frog. That's a squelching frog, right? They're identical. They don't look that identical there, but when you actually see them in the field, they are absolutely identical. The only thing the difference is one likes sand and the other one likes granite. So when you're actually mapping them, you can actually map the granite rock coming from Darling Range all the way down past Bunbury out to the ocean, down through Yellingup. And the little bleating frogs, these guys, will actually follow that granite outcrop. So they're geologically, you can actually work out where you're at with frogs. That's another one of these little creatures. This is when it gets you, they can really play with your mind. So this is a white-bellied frog, and you've got this, okay, we're going out frogging. Okay, got the castanets, Okay, I can distinguish between these two. This one here, pretty much on the cliff edge of leaving the earth. This one is quite a it's a bit more general in its habitat and is okay for now. But then you've got another set of castanets. The non-indigenous frog. You've got this little guy, whopping 2 centimetres long. You know, it's like they keep on going, and like you take kids out, and that's the other thing about frogs. They're intergenerational. There's a lot of older people here. You go out to give a night walk, and the old people are leading the charge because the younger kids haven't been out on a night walk before. And they probably don't have the night vision happening as well because they've been looking at this too. It's true that when you actually don't develop your eyesight and you've got this happening at night, you don't develop it. And I walk around the house all the time with really low light, and the boys go, "Dad, I can't see anything. I can't see anything." But it's just one of those things that you are used to. And unfortunately, with the age of these, they are a tool, and unfortunately, they can, You go out at night, because you know frogs are sleeping when you're creeping, and you just got to be aware that that's why are they calling at night?
So predators can't see them.
Predators can't see them. What's the other thing? It's got to do with their physiology, because they have underdeveloped lungs, so they breathe mainly through the skin. And can they smell?
Yeah.
Well, no. What the thing is that they don't have an olfactory nervous system, and so they can't really smell as such, and that sets them aside from cane toads because cane toads have got olfactory nervous systems, and they can smell and they can exploit sedentary like dog food. Cane toads. So pretty. If I'm coming back as a cat or a cane toad. So right. You take a bunch of kids out and it's like there's owls, there's monkeys. Oh, and the iconic moaning frog, which probably disappearing from land, and it, like we've seen a lot of them, Jackadder Lake and Lake Mungo. A lot of these areas through here are denuded of the particular moaning frog, and I've got to skip along. All right. I'm sorry, I can't get to the rest of the calls because I've got to hurry up. The ground frogs. Okay, they're them. They're the colour of the ground. They're the biggest ones. The quackers. They're about 4 centimetres. The rest of them are pretty small. So what we're trying to do here is you understand. One of the things I don't do is talk about the motorbike frog, because the motorbike frog is a big frog, and they're like ravens and robins. I'm talking about the robins. So when you look at the upside down pyramid, you've got to look at these little guys as a food source. Whales and krill, they are the food source that feeds the rest of the system. So you've got to turn you upside down like this, and then you've got to go, when I'm doing a re-veg project, this is what I'm monitoring for to see if I'm doing the right thing. All right, so that's I was going to do a little frog ID and a little work out the sexing of different frogs, but we'll bypass that. There's the different kind of burrowing frogs. This one here gets Mr. Lawton. It's the first footer. It'll be called going from like the end of March, and that's a trigger for a lot of our frogs to start doing their thing. And what they do is they live in the upper landscape, and it's a trigger for them to start coming down from that upper landscape. The turtle frog, and that's got no water dependency at all. And there's a suggestion that they actually pair up. So they're calling now in the dry Banksia woodlands, and they don't breed until April. And they can burrow more than 3 metres. They're front-way burrowers. I know they can burrow more than 3 metres because the trials that we were doing with them, we had them in these sumps, and it was 3 metres and they burrowed out. So yeah, that's how we know. That's the ticking frog I was telling you about. We did look at it. It actually leaves its eggs up on the sedges, so it gives you an idea of the breeding biology of some of our frogs up out of the water. These are our tree frogs. Sure enough, they probably get people see them as being the frogs. I don't talk a lot about them. These are one of the frogs. These are quite habitat specific, but the motorbite frog is pretty much a generalist and would survive pretty much a lot of stuff. So where I'm talking about is when you're looking at your continuum, your reveg. One of the things, remember what frogs eat. What do frogs eat? Insects. What do insects need? What do they eat? So, and what do they need in their habitat? They need shelter, and they mainly eat vegetation. And so you need to make sure that there's a bit of a vegetation. That the leaf litter is important when you go out frogging, especially at this time of the year. It actually gives you a really good idea on what the frogs need. Summer is a great time to go frogging because frogs are really like, you know what you're looking for. You can find frogs pretty quickly. There's the frog life cycle. I wanted to reinforce that plant herbivores, but mainly carnivores. They're carnivores, they're site creatures. So they eat insects. This talks about the different breeding and associated habitats of the ground frogs and the burrowing frogs and the tree frogs. The burrowing frogs are the ones that live in the dry landscape for the majority of their lives, and they can't swim that well. So the first rains are, when you hear the first rains, the males have already come down to their seasonal wet. And if you let your retic on, they should have been used by the water corps because they are the best indicator. They're the most watered, independent kind of frogs that we have. But when they come, when its first, second rains come, all those frogs that you run over in your car, they're female frogs because the boys are already down there. I'm in a hurry. Now it gets really complex, but it doesn't have to be. If you really want to map each of your frog species, this actually goes. I've got this for autumn, winter, spring, and summer, with all the different species that need to be mapped in the southwest. Quite a lot of work that actually talks about where they live and all their different all their different types of biology, how long they're going to be eggs for, and what their preferred habitat for outside of breeding season. These are the different kind of habitats. Look, this is just wanted to show you. If you think that's a good breeding area for frogs, well, for tadpoles it's good, but the frogs need to live throughout the year, and so there's no area shelter. There's no shelter there, so there's no trees, and those trees drop the leaves. The leaves the little insects live in, and also there's lack of low down kind of herbaceous grassy sedges. Those grass sedges, like just out here, what needs to happen in there we need to put in some herbaceous kind of wetland, boggy kind of plants like the lobelias and the goodenias and things like that. Centellas. There's some centellas I've seen over there. But what it is, it's about the microhabitat. When you're out frogging in the summer, spot the frog. There he is there, and this is a centella. So this plant is transpiring and it's creating this little bit of moisture. And in the middle of summer, your little crinias love that because there's two things: there's tucker, but there's shelter. There's the cotula, that's an annual. So in your actual re-veg, incorporate stuff like sour bayers and cotulas and things like that. Don't be afraid to throw some seed out of annual plants, of annual herbaceous plants. I've got to skip to this. I just wanted to bring everything together and you understand what I've talked about here. Know your target species. Your revegetation attributes. Logs are good. Logs are really good because inside there's this interface of moisture. In that moisture, insects interact with it. Insects interact with it, food for the frogs, so they don't have to go too far. And so there's that happening as well. The trees, you need the trees. You need to cover your westerly kind of aspects to make sure that, like in this time of the day, and the frogs will actually follow that circle around. So make sure that there's ample vegetation below your trees, and incorporate the eucalypts into your vegetation. The microclimate, make sure you understand what your food sources are for your frogs and for your other animals that are in the system. The insects are the thing that you need to look at. Rightio. The late Ken Applin and all these people, Jackie, Lani, she's critiqued my presentation, splashed lots of stuff out, thanks to Jacqueline from the WA Land Care Network. And hang out with your elders. Hang out with your elders from these societies. Because when you're talking about animals, I always talk about plants. So, you know, when I'm talking about plants, I talk about animals. So you've got to know the difference. Okay. Just one.
These guys are starving.
Just one more thing. If Kermit was a frog, and he was in, well, Kermit is a frog, isn't he? He said something. He said it's not easy being green. He was a Western Australian temperate region. He'd say it's not easy being brown. Right. Thank you.
Thank you.